We're doing a section. If you look at the 5th and 6th and 7th bullet points in the competent. Okay, that's what we are covering. We are covering, you need to provide an accurate graph of the mass of waste per day for each location. So how much waste does each location put into the river in kilograms per day? Okay, and the one below that, calculate the total waste at each location in kilograms per week. Okay, so if we know how much they're putting in every day, we can easily figure out how much they're putting in per week. Okay, and then you need to estimate the percent of the source's total waste production that's being dumped into the river. Okay, your case studies tell you how much is produced at each location, and you're going to compare that to how much they actually dump into the river. You know, are they putting 100% of their waste into the river? Are they putting 20% of their waste into the river? Are they putting 2% of their waste into the river? Okay, so that can give you an idea of how hard they're working to keep what they put into the river minimalized. Okay, so we're going to start, and the two pieces of information that we need is your volume flow rate and your parts per million. So I'm going to show you where to get those. Volume flow rate is what you were doing as in your calculations yesterday. So some of you haven't finished that yet, but you've at least started. Some of you are done with those. So I'm going to take location 1. We're going to start at location 1, and we're going to look at its. I'm actually going to start at location 2 for another reason. They'll let us go through all of those steps. But location 2, we want to know its volume flow rate in liters per day. Okay, so we're looking for this number. Okay. Liters per day. Okay, those units are helpful and necessary. Okay, so we need to know how much water it puts in every day, and we need to know the parts per million of waste that it puts into it. Okay, that can be found on your initial data and pollutants. So somebody pull up the initial data and pollutants and tell us what the parts per million are on a day for location number 2.
What?
Parts per million.
13.175.
Okay, is that Monday?
Yeah.
And it changes every day, right, Vinny? Okay, so this number is going to change every day. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, it's different. Okay? And so you'll need to calculate this for each of those days. Now, when you first look at this, it's going to seem like a lot of calculations. I'm going to show you how to do it in an Excel spreadsheet or a spreadsheet so that it goes much more quickly for you. So this is 13.175 parts per million. I'm going to give you a little definition of what parts per million are. Okay, let's say I've got 1 million molecules or water molecules in here. So I go out to my river and I collect 1 million particles. Okay, so 1 million particles. Okay, what this is telling me is if I were to look very, very closely at that, 13.175 of them would be waste coming from that. Okay, obviously I can't have a 13.175, so it doesn't work when we're looking just at 1 million, but I would have 13. Okay. So the waste, I would have 13 parts per million waste. If I have 1 million things, there's going to be 13 of them that are waste in that situation. Okay? So that's kind of what that means. Give me a fist of 5 if you understand what it means to be parts per million. Everybody. Skylar? Okay, so put the phone away and you'll be able to pay attention. Don't lie to me. I'm sitting there watching you, playing underneath your desk. Don't act like I'm stupid. Okay, pay attention on it. One more time for you. Okay, if I go out to my river and I collect 1 million particles, if my parts per million are 13 parts parts per million, 13 of those million particles will be that particular item. So you're going to look a lot at different, like DO, you're going to look at benzene, and you're going to get parts per million and parts per billion. They're going to mean the same thing. So if something's 15 parts per billion, that means if you look at a billion particles, 15 of them will be of that type. Okay, it's a concentration amount. Okay, now let's do Vista 5. Anybody? Everybody. Okay, so you've been fist both times. Why are you fist both times? Are you paying attention? Why don't you stick your phone right here? Just stick it right here and leave it there. Okay? Pay attention, guys. I'm not doing this because I just want to talk at you 17 times in a moment, okay? I want you to pay attention, and I want you to learn and understand these things. So please pay attention. Okay, so we've got 13 parts per million at this location. At the top of your initial data, what does it say about parts per million? It's going to tell you some information that we'll need.
Equals milligrams per liter.
Thank you. Okay, so if you look at the very top, I even went back and highlighted a couple of things so that you make sure you see them. As it says right there, 1 part per million equals a milligram per liter. Okay, so if I have 13.175 parts per million, how many milligrams should I have in 1 liter? I should have the same amount. I should have 13.175 milligrams of that waste. Okay, that conversion factor is very, very important for us to figure out how much mass in kilograms we have in each volume of water that goes past the location in a day. We've essentially got the amount of water that we have to deal with and how much of that water is waste. Does that make sense? Yes? Okay. So we can actually just come and change these units to milligrams per liter. Okay? They're equivalent. They mean the exact same thing. So I'm going to show you how to start this in a spreadsheet. Okay? So we're going to start with location 2. Let me make it bigger for you. Okay, so you can see it. Location 2. Okay, some of the information that I need is the volume flow rate on each day. If you have someone on your team who wants to, it's a good idea to start. You could start this. Okay, so I need to know each day, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and then you know the volume flow rate. In the case of location 2, it's the same for all of them. Okay, my volume flow rate is equivalent for all of them. I also need to know my parts per million, which I'll convert to my milligrams per liter. Okay, that's what we've covered so far in our discussion. So what I'm going to do is I'm just going to get my volume flow rate at location 1, excuse me, location 2. Now I've got these in a spreadsheet. You may have them on pieces of paper, so you just need to put them. All right, so I got that. I need to get my parts per million. Remind me where we get our parts per million. The document that has the initial data on it. Okay, so initial data and pollutants. We're going to zoom back out. Okay, so I'm at location 2, and they all give you a total measured pollutants parts per million. Every single location has them. Okay, so that's given to you. Easy for you to access, easy for you to use. Okay, so I'm going to just copy these. I'm going to copy all of my locations, and all my parts per million, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday for location 2. Okay, I'm going to put those here because they are my parts per million. I don't know, there must be an extra cell on there something like that, I don't know. Okay? So that's the information that you've calculated and the information that's given to you. What did we say about parts per million and milligrams per liter? They're the same. So part of what I'm going to show you is how to make Excel do these calculations for you. Otherwise, we have lots and lots and lots of calculations to do by hand, lots of numbers to mess up on, and so I'm going to show you how to make this do the math for you. Okay, anytime you hit an equal sign, you're starting an equation. But I'm just going to say that milligrams per liter is equal to whatever's in the cell next to it. Okay, and it's just going to copy that over for me. Okay, I could have just copied and pasted, but I'm getting you into what formulas can do as well. Okay, so I've calculated milligrams per liter, which is parts per million. They're exactly the same. So we said 13.17 milliliter parts per million is the same thing as 13.175 milligrams per liter. Okay, so my volume flow rate is in liters per day. Okay, so how can I get to figuring out how much waste is in my water? Any ideas up there? Let's look at the sets of units that we've got. We've got liters per day, and we've got milligrams per liter. What type of thing, what information do we want out of this calculation? We want to know what? What does it say on your rubric? We already got liters per day. What does it say on your rubric? The waste per day for each location. We need a mass per day. What math step could we do to end up with mass per day? This is a mass, this is a day. We multiply, those will cancel out. Correct? Okay, so all we're going to do is we're going to multiply whatever is in our volume flow rate by our milligrams per liter. Okay, this is where the situation gets of having too much math to do. Right, type in 107724416085 times 13.175, and then write that number out. Is a big process. Okay, but let's figure out what it is. Let's calculate what number we would have. Who's calculating it? Multiplication. Somebody's got to calculate. Yeah. Multiply this number by this number. Too big for your phone, right? That's what we're told. It's an awfully big number. Is it too big for your iPad, Zach?
No.
You got it? Okay, tell me what it is.
1.419266.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, that's my number. That wasn't very fun. So then have to do that every single time, right? So I'm going to show you how to do it easier. Okay. Again, a spreadsheet can do simple and complex math for you. Okay. If I want to start it, what do I want it to do? I want to multiply two numbers, right? So I'm going to say equal. That's going to start my equation. I want this number, whatever's in that cell, multiplied. So shift 8 by this number. And it's basically the same number that we had, right? But it's done it for me. I don't have to do any typing. Okay? I can go through and I can type that in. Sorry. For everyone equals this number times this number. Okay? That's still a pain, right? To have to go in and click every single one. So what I can do is if I have this little box down here, you see how my cursor turns into crosshairs? Okay, once it turns into crosshairs, that's going to allow me to copy that formula. So all I have to do is then drag that down, and it's going to copy that formula the whole way. Okay, so much, much, much easier for me to do all of those calculations.
What was the formula again? He's doing that.
Liters per day times milligrams per liter. There's the formula. Equals this cell times this cell. Okay? Christina, you can also see my formula up here.
Oh,
Okay? And if you click on a cell, it'll show you the things that it's multiplying. It's multiplying this by that. Okay? Alright, so I now have a mass per day. I get a certain number of milligrams per day. But what does my rubric want it in? What specific mass? Kilograms, right? I'm in milligrams. So we need to figure out how milligrams are related to kilograms. How many milligrams are in a kilogram? More than 1,000, because a milli is 1,000. So there's 1,000 milligrams in a gram, and then there's 1,000 kilograms in there's 1,000 grams in a kilogram. Okay, so 1,000 times 1,000, which is 1 million. Okay, so I need to do what with this number? Not multiply it, divide it by a million. So how would I do that using formulas? Okay, equals this cell divided by 1 million. And it's going to do that for me. Okay, and then drag it down, and it's going to do it for me. The milligrams per day divided by 1 million. Okay? Okay? So I've now got it in kilograms per day. Okay? So I have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. You need a graph of that. I'm going to do this for you. Make it a little smaller. Okay? I need my Monday, Tuesday, Wednesday over here to make my graph look nice. Okay? You're going to need a graph of that. I personally don't like all of these decimal points, so I'm just going to change them to 1 decimal point. Okay, so there's my amount. I need a graph of that. I'm going to highlight Monday, Tuesday, Wednesday, Thursday, Friday, yada, 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 and how much each week, and it's going to build me a graph. Okay, I can go through and I can customize that. You should customize it. You got to get the right labels and things, but you should be able to do that without me showing you how to do that. What?
Is that how you want the graph?
It just needs to be a graph. If you want it to look like this, it can look like that. Fine. If you want it to look like that, it can look like that. You just need to show me the amounts. Okay? That's what one of those. Okay? You can go through, I don't need to show you how to do all of this, but that's how you would generate that graph. Okay? Alright, I also need the total per week. How can I get the total per week? Add all of those up. So I could go through and do 141,926.6 plus 168,480 plus, but I can use a formula. What formula could I use? Okay, so I could do equals this plus this plus this, right? But that's still too much work for me. I don't like to work that hard. Okay, so I'm gonna do this, sum, okay? So it's going to tell me, it's gonna add all the numbers in a range of cells. So all I have to do is say equals sum, and click all of the cells I want it to add up. Okay, it's gonna sum all of the numbers in G4 to G10. And then if I hit enter, it's gonna add all of those up for me. Okay, that's another shortcut. You don't have to actually go through and create those. All right? Okay. Now let's look at, so you can repeat that process with 1, 2, and 3. Excuse me, 1, 3, and 4, because I did number 2. Okay, so you can go through and you can duplicate that process. I'm going to show you one other thing. Let's look at our initial data. This is a tip for you. What is it? What's highlighted? What's the top paragraph say? Okay, scientists taking the data estimate that due to dilution and absorption by the riverbed, only 50% of the pollutants from one location make it to the next measurement location. Okay, so whatever pollutants are in location 1, half of those make it to location 2. And whatever pollutants are in location 2, half of those make it to location 3. Okay, so I'm going to show you, we have to account for that. We want to know exactly what location 1 is putting in and not what, so at location 2 we want to know what location 2 is putting in, not what's still around from location 1. Does that make sense? Okay, so I can show you. I've got this over here. This is the exact same steps that you've done just for each of the layers, so each of the locations. So if you want to check your numbers, I have them calculated as well, and you can come check them with me. Okay, so what I did in adjusted, if I double click, I've taken, okay, whatever is in here, and I'm subtracting it by whatever happened on Monday at location 1 divided by 2, because only half of it's going to make it there. So I'm taking out whatever was still in my river at location 1 and saying it doesn't come from location 2. Okay? And I've used that same formula. I'm taking this minus this divided by whatever it is, divided by 2. Does that make sense? Somebody in your team got that figured out and know what I mean? So you can see what that does is it actually makes my numbers a little bit lower, right? Because I'm taking out, I'm not accounting for whatever was left from location 1. Okay, so I'm getting rid of some of those numbers. Same thing is true for the all of them. They're going to be a little bit smaller based on that. Okay? So, you'll need graphs of each day of the week, like these. Okay? And you'll also need a total pollutants at each location. Okay? Those are things that you'll need in your presentations. And you can get those all from here. Any questions I can answer for you? So I'd recommend you start on that while it's fresh. Yes, Grady?
Can you go back to one spreadsheet?
Yes. Okay, so I'll leave this up here if you guys want to look at it to help you figure that out. Ivy, did I miss anything that we covered? Okay, just make sure I didn't forget any hints. Okay, so you should certainly be working on that. I want to see your progress on that tomorrow. I'll be checking in on that. So you've got plenty of work to do and time to start.